Good morning, class. This is our last session as we are going to answer the problem in the final exam. Last time we were able to answer the sequence control with the logic decision, and this is much easier, a lot easier compared to that problem. So we're gonna go directly to that problem being considered, right? So here is the sequence of the problem. There are seven. No, there are seven cylinders, and here are the sequence: A, B, C forward, then cylinders D, E forward simultaneously, F, G forward simultaneously. Then when they go back all at the same time, now they are going to return all at the same time. Okay, so let me put the notation here so that we can start solving the problem. So the sequence, so here's the sequence, no, for the seven cylinders, right? So A plus, B plus, and C plus, no? And then after that, the cylinder D and E will forward at the same time, right? A plus, B plus, C plus, D plus, E plus. Now, so how many cylinders do we have right now? Five, right? A, B, C, D, E, then E, F, because there are seven cylinders in total. So E, F, yeah, is also at the same time, right? So look at this. A, B, C forward, then D, E forward simultaneously, F, G forward simultaneously. Okay? So ABC forward, so meaning sequential. A plus ABC, then DE, then EF. Then the sequence at the last is the return, and the return is being um, administered or given by the sequence like this. Now all at the same time: A minus, B minus, C minus, D minus, E minus, F minus. Okay, yeah. So what is the first thing that we are going to do? So the first thing that we are going to do is to identify how many motion sequence are there in the system. So A plus is one, B plus is one, and three is one. So one, two, three. Then D and E at the same time going forward. So because it's a time function, no, they they consume only one, no, set of time for two motion, no. So whatever time is involved, so that's gonna bring the the forward of the two cylinders all at the same time. So that is what we're talking about here. So now in the EF, same thing, no? So that is the motion 5 or sequence 5, and here is the 6. So there are six movement happening: one, two, three, four cylinders, two cylinders D and E, five, two cylinders again E and F, then A B C D F. Okay, A B C D E A B C D E F, A B C D E F, right? So A B C D E F. How many cylinders do we have? A B C D E E F. A, B, C, D. Oh, wrong, wrong, wrong. D, E, F, G. Sorry, sorry. We were. I made a mistake. I was able to make it double, right? So F, G. Yeah. So this one is F, G. So A, B, C, D, E, F, G, right? There are six, and then as standard, we'll have a reset for this, right? So we have a provision here for resetting, meaning putting all the system into its original position, which is off or reset. Now, everything, the outputs and the inputs are off. So as we said, we have to assign each relay for each motion. So we assign this as R1, we assign this with R2, we assign this with R3, this with R4, this with R5, and this with R6. But we have another R7, the relay 7 for the reset. Okay? So we were able to make this clear before, no? We are going to use relay in the hard wiring, but we're going to use internal relay if we are going to use PLC or other controllers like microcontrollers and others. If they have internal relays or the solid state relay inside the controller, we can use that address. But for now, what I'm teaching you is the hard wiring using relay. So talking about relay, there is I told you the relay is like this. So if I may review, so parts of relay. So this one, the relay and the contact. Yeah. Okay. So basically, what we're going to use is the relay like this. So let me review you. So this is the electromagnet because the relay device is an electronic or electric device that transmits electricity using electromagnet. And this electromagnet is um, having a effect, no, which we can identify as this. Now, so whenever there's an electromagnet, meaning a magnet that is being powered by electricity, it will produce current, no? Because there's a voltage when you put that in 24 volts. For example, when you supply that relay with 24 volts or 110 volts AC or 220 volts AC. So voltage there, then the current will be produced because the current is just the rate of the movement of electricity. So we will have a current, then we will have this flux, the flux density here happening here, and the force, right? So one of the conspicuous manifestation of this electromagnetism in relay is the force, which is basically a movement of push or pull, right? So whenever there's a current and whenever there is a flux, so here there will be a force, no, and that force because of electromagnetism will tend to move this lever, right? So this is the so-called lever or armature, no, and then it will be pull or push. So when it's pull, huh, from normally close, it will go here to the normally open. Yeah? So from normally close, it will go here. So this one will be the normally open and this will be the normally close. What we're saying is this, yeah. For the normally close, it will become normally open, right? For the normally open, it will become normally close. So it's here. Now what we're saying is this, right? So right now, it's like this, right? This one. It's normally closed, right? But when there is this electricity, then it will become an open, right? So this is a terminal one, right? Terminal two. Okay. So that's another representation. No? And then if you pull out the power, then it will go back again there in the if there's no power, it will go back to its initial condition, no? In its normal condition. Why? Because our armature or lever is mounted na by a spring, no? So when the electricity is more, so it will pull, hihigupin niya doon. Pag tinanggal mo naman yung kuryente, so it's not going to be an electromagnet anymore. There's no magnetism happening because there's no electricity. Then by virtue of spring, you know, it will go back, no, due to tension and compression. First, it will be there tension, it will go up. Now when this goes down, this will go up. Then when you remove the electricity, no, because of this tension, it will be going back to normal. No, because once the spring is stretched, now in this case, it's a tension spring. It's not a compression spring. It will be stretched upward. Then it will go back to to the normal position, going here in the initial position. So this one, it's going to be in contact. Then when you remove the electricity, it will go back to its original position, which is normally closed in that upper case, no, in that upper uh, level of the drawing. Yeah. So that is just a review for our explanation. So now we go back to this. Now, so immediately we will lay out the foundation here. So here we'll just have make it very quick, right? So first we rewrite again so that we can see here now at the upper part, A plus, B plus, C plus, then D and E at the same time, right? And then F and G at the same time will forward, right? So this one, A plus, B plus. And then all this, now A, B, C, D, E, F, G will have a minus or return. Now, and then we will have a reset. So what we're going to do is this. Now, we have to know what are the elements that make each other actuate, no? Or how does the sequence go? So we need the stop push button to effect A plus. Then when it has A plus, it will touch A1 to give signal to B plus. Then B plus will touch B sub 1, small. Then C will touch C sub 1. D and E, there are two sensors. So D and E will have D1 and E1, right, for the FG. When FG is already done, when they move forward, they will touch their extended position sensor, which is F1 and what is this? G1, no, for this. And then this one has a lot of sensors. Now the sensors here for the reset, no, we'll place it in parallel. What are the sensors? A, 0, B, 0, C sub 0, T 0, E 0, F 0, and G 0, right? So these are the sensors for this. So this one is for this, B is for this, C is for this, D is for this, E is for this, F is for this, and G is for this, right? So we can now start the relay ladder logic, okay? Oh, sorry. So right now, what we're going to have is the relay ladder logic method for the solution. So this is what line one, and this is going to be line two. So all we have to do is to lay out and plug in all the relay that are involved. So R1, R2, R3, R4, R5, and this whole thing here is R6. And then, of course, the reset is R7. So do we have basically seven, right? So one, 2, 3, 4, 5, 6, and 7. No, so we'll put that here. So we make this as R1, R2, R3, R4, R5, R6, and R7. Okay. So in order to help the designer or the mechatronics engineer or the implementer of this, you could put the tag on the right side to be visible. So R1 is responsible for what? A plus. What about R2? R2 is responsible for B plus. R3. So R3 is assigned for C plus, cylinder C. And R4, R4, it has two main tasks, but B plus and E plus, right? Then when you go to R5, R5 is assigned to two tasks, no? F plus and G plus. Now F plus and G plus. What about R6? Oh, there's a lot. So R6 is responsible, R6 is responsible for the retract of the seven cylinders. So since it's very long and I could not kind of accommodate this in vertical manner, so I just have to use horizontal. A minus, B minus, C minus, D minus, F minus, A, B, C, D, E minus, F minus, and G minus. So all of these are happening at the same time when R6 is activated. And then here comes the final motion, which is resetting all this, right? Now, so we start, okay? We start now with a sequence. How do we effect A plus? By the way, let me put this. So for the benefits of all those, especially for those who are not familiar with the cylinder action, no. So what we're saying is we have seven cylinders, right? This one, cylinder A. Now we put this as cylinder A. Then cylinder B, we have that this now. Then cylinder C. Okay. Then we could have this as what are the other two? DE, right? So let us put it here. So here is the piston, here is the rod, right? So the two. So we have cylinder D and cylinder E, right? Then we have two more. So what about this? Cylinder E, this one is cylinder F, and this is cylinder G. So we have seven, right? So this is cylinder one, which is A, two, which is B, three, four, three, and then four, five, cylinder E and E, cylinder D and E, and then this is cylinder F and G, which is six and seven. So there are seven cylinders, and of course there are seven solenoid valves, no? Solenoid valves, and there are only one compressor is needed, no? So what we're saying, according to the problem, there is four two-way valve. What is four two-way valve? Here is the four two-way valve. So each cylinder has a four two-way valve spring return. So if I can draw this, so this is a four two-way valve right here. So this is here in this port, and this is the port A of the cylinder. It will go here to the atmosphere. right? Exhaust. So what about this? So this is like this and this like this. So the power or the compressor is coming from this side. So we have a power of compressor here, no? Power, air power, no? So where the pressure relief valve is there, where the the filter, no? Regulator, lubricator is there, and the motor is there, no? So motor, and there's it's driving the compressor engine, no? Whether piston or other, right? So each one has that, no? So if I may put it here, this is the spring, and the complete name is for two-way valve single solenoid, right? So the solenoid here is the electromagnet, no? So it's like this. It's like a relay, no, but only different configuration. But inside the solenoid, it's like this. There is an electromagnet inside the relay. So each one has this, no? So if I may patiently do it for you, so this is the four two-way valve. So there's another four two-way valve here. Or forgot to place the spring, right? Right. No. So here, there's a four two-way bulb here. There's a solenoid. There is this arrow, only arrow, no, for the representation. Then there's spring, no, because it's just a symbology, no. So meaning the symbol is just used, no. It's not a pictorial drawing. Instead, it is a symbol. No, pictorial is more of the actual picture. Yeah? So this one, right? So all those things, yeah, so they're here. No, we put here. There's another four two-way bulb here. There's a spring, and this is the arrow. The arrow that explains or that signifies the direction of the air, and where is the air power would be going, right? So this one is like that. No? Okay, so there's a spring here, and then there is the solenoid valve. So each one has a solenoid valve, right? And all this power are connected to the compressor. So for example here, right? So all these are connected, common line for the compressor, for the compressor. So this here, so this here, right? So you can have a valve manifold so that you can have seven lines, no, for the supply, right? So, for example, here is coming from the compressor. So all these, for example, all these are attached here, right? So here is this for the power, no? So everyone is getting power from the compressor, and you can have manifold, not to simplify this, no? So once it is it is activated, so the valve will open only for this, right? So that is the power, right? And the others are the other line is for the exhaust. Okay, so I think I made it clear, except for one last thing because I wasn't able to explain why was it called 4-2. 4-2 way because two position. What are the positions? The positions are front, I mean the forward and reverse, and they are represented by the box, no? So if you see a box, you just count the box. So I have one box, I have another box, so two boxes means two switching positions. There is no middle, there's no stopping in the middle, right? So the other is the connecting ports. So when you have the connecting ports, you just have to count, no? Where are the pipes or the tubes be mounted? So one is here, that's P. Then here is the exhaust, normally R or S, meaning release, no? And this one is for the A, right? And B, port A and port B. So one, two, three, 4. That's why it's 4, right? So 4 two-way. No? So 4 is the number of what? 4 is the number of ports. Now, where do you put the tubes? Where do you connect the pipe? So 1, 2, 3, 4. Then the 2 is the position. One box and another box. Okay? So I think we're very clear with the electro-pneumatic. This is the electro-pneumatic configuration or plan or design, no? Circuit, electro-pneumatic circuit, no? But what about the electrical? Because we're after the electrical or electronics because that is where the brain of the system is located. Now, so what we're going to have here is to follow just to follow the sequence. Now, we need a start push button to effect A plus. So I'll put a start push button, and the symbol for that is this, right? Start. And as a standard in electrical wiring, in every plant or every system, if there's a start, there is a stop, which is normally close. Pinano mo na? Remind mo? So this is the stop. No? So one is normally open because there is a gap, which makes it normally open, and this one is already having a contact, and that makes it normally closed, right? So if I just uh, ex- explain in detail. So let me erase that so that it will give us more space. Right now, so R1, it is said that R1 or the relay one, this one, no? So one of this, no? One of this is responsible for A plus. And how could that happen? So we'll show to you how will that happen. So here's the control circuit. We call this control circuit because it's for controlling. Most of them are relays and sensors and others. And the other is power circuit. Let me put that here. It's just the same, right? Because it's just powered by line one and line two. No, but we lack we don't have enough space. That's why I put this on the right side of the screen. So if I put a finger press, no, if I press this push button, no, push button, if I press, what's gonna happen is it will have a contact to the terminal. This one, right? So when the force is going like this, so it will have a contact. So the electricity is now continuously flowing, right? So I put exaggeratedly. Now with exaggeration, I put the power here. It can go transcend here, energizing R1. Now, so what is R1? So it's a relay. So R1 is a relay that has a electromagnetic coil, and then it can change the status of, yeah, it's like this, right? Mm. Yeah, so this is the relay. Yeah, so this is the relay. Now, so let me get a very good representative of a relay. Yes, I think it's here, right? So that mm, I'll put it here so that you can always see what's happening. No, so one of this here, one of the relays is now being active, and the address or the name or the label of that relay is relay one. So this one, no, we use one of this, no. So kumuha tayo nitong isa, and then we all know that this is normally closed kasi nakapalo na agad, and pag pumalo siya sa kabila, normally open. Na pinakita ko naman na sa inyo lahat, no. Ito yung normally closed. No, look at this so that you will understand what's happening. This is normally closed, right? Because it's already closed, right? Yan. Pa? And it's normally open. Okay? What's going to happen is if you put electricity in the electromagnet, this will energize, and this will produce a force, and that force, no, because of electromagnetism or magnetism will try to push or pull, no, depending on the pole, right? Of course, it was designed in such a way that when you place an electromagnet here, when there's a electricity effect here, it will become electromagnet, and this will be pulled, no? May hila siya downward para makakontak siya rito, di ba? So that it can have a contact here, right? And the spring will have a tension going upward. Now, so that's basically what's happening in the relay. So if I may continue, what's going to happen is this. Now, if you put a relay, if you put the electricity in the relay, what's going to happen is this, no? So there's this relay will be energized, no? And then this line two, no? So if there's an electricity in a closed circuit between line one and line two, and this is the output, right? The ones that you're going to manipulate, and this is the triggering system, meaning the switches. So normally the switches and the sensors are located at the left side of the relay ladder logic circuit. No? In the circuit or electrical circuit, the switches are located somewhere on the right, on the left side. So here, no? So left side. On the right side are the outputs or the relay. So let us take a look at this. So normally we put a latch here so that even though I am no longer pressing this, no, still there is electricity given by this, because there will be a parallel uh, road, no, parallel way. Now there's another way so that this electricity can come. So in electrical term or language, it is called latch or holding contact. Okay. So now still the relay is energized. So what about here? No, in the power circuit. Now we should put a line. Now from line one, we will have a line going to the normally open contact, and from the normally open contact, we will put the sol or solenoid A, na, for A plus. Now the question is, have we achieved the A plus? Did we ever achieve the forward motion of the cylinder? Yes or no? So here the electricity is here, not coming from here. It could come here or it could come also here. Now because once this is energized, this will become closed, no? R1. So all the contacts of relay coil R1 will be affected, meaning the normally open will become closed and the normally closed will become open. So this one is normally open, it will become closed. Why? Because the coil was energized and there's this force that tends to flip, to change over the contact position, from normally open to normally closed. So what's happening now is this, that electricity, now I'm exaggerating the signal, can come here. Now it's also line one. It's just a continuation of line. Then it can jump, it can continue, it can pass. Now passing to this contact of R1 and then energizing the solenoid and then going to line 2. So you have now a closed circuit, right? So from here, then to the output, and then to the line 2. So what's happening? Where's that happening? This here, no? So cylinder A, the responsible for the relay responsible for this is relay 1. So relay 1 will send the message through its contact normally open right here. So the normally open contact will become closed, and then it will be a conduit, a passageway for the electricity to come and energize the solenoid. And where is that solenoid A? Right, you are right here. The solenoid is here, right? So we call this solenoid A. So it will become energized. When this is energized, it will switch over, meaning this portion will come here. So if I will put here now, so it will become like that. No, so it will become like that. So this one will become here, and it will supply air to this, not to the piston side. So once the air is filled, no, when this air space is filled out, so it's gonna push here. Now it becomes A plus. So how does it push? Because you have a cylinder that is the cross-sectional area is a circle right here. No, so this side view here is this, right? So our area is circle, now pi d square over 4. And then from the elementary formula, pressure is a force acted upon per unit area. So if you want to have a force, you just have to multiply the pressure and the area. And that's going to give you a force, right? So how to get a force? You have the area and you have the pressure coming from the compressor, normally 6 bars or 8 bars, like 70 to 110 psi. Now it's a fairly good amount of air, because the air in your car, in your sedan or Jeep is 45, no? 30 or 45 or 25 psi. But this one is 70 to 110. So it's a big amount. Huh? So when there's an area and there's a pressure from the air coming from the compressor, so you're going to have a force, right? This one now. So let me put it here. So force is pressure times area. You have a pressure coming from the compressor, that compressed air making the pressure high, and then the concerned area is the circle. Then you're going to develop a force, no? And that's going to be forwarding its rod, right? So when it's forward, it will touch A1, right? Because this one is A0, A1, B sub 0, B1, C0, C1. So these are the electromechanical sensors or electromechanical switch. Now, if you don't have sensors, which is electronic or solid state relay, so electromechanical switch. Same thing here, D. So we have D0, D1, E0, E1. What about here? We have F, null, F1. Now, the sensor or the electromechanical switch, right? And this one is what? G0, G1. Okay. Okay. So these are called electromechanical switch, or the so-called limit switch. Okay. No? So you should understand that there should be a switch or sensors, no? So that the sequence could take effect. For those of you who are not yet familiar with the electrical or electromechanical limit switch, no, or sensors, let me go to the electrical mechanical switch first, no, so that here, right? So para maintindihan ng mabuti, ito yung sinasabi natin. Yung cylinder tatama dito sa roller. Ayan o, may roller yan on the upper right corner. There's a roller so that the cylinder rod will just have to bump this or actuate, no? So what I'm saying is this. Yan, no? So yung cylinder, yung dulo po ng cylinder will have to touch this, right? So yung cylinder, may rod, tatamaan to. Yan, oh. Yan. So depende kung naka-wire yan ng normally open or normally closed, so bababa yan. Pag bumaba yan, may mangyayari doon kasi may spring. Either yung normally closed, mag-open, or yung normally open, di ba? Normally open, yan, no? Magko-close. Yan. Ito yung switch, no? Or sensor. Pag sinabing sensor naman, yung nga nasa loob ng cylinder, papakita ko lang no, para at least naintindihan kasi wala tayong maipakitang actual. Ang tawag normally doon, ang tawag sa nilalagay sa cylinder ay reed, no? So magnetic reed switch for cylinders, no? Switch for cylinders. Oh, tingnan mo. Image. Punta tayo sa, we go na to the image so that you could, yan, no? So, ayun, ayun. Ito, nandito mismo siya sa cylinder, no, para makitang mabuti. Ito 'yon, no. Nakikita mo ba 'yan? Ayan, no, nakikita mo ba 'yan? Yeah. So meron siyang reed switch, no? SMC, bawa yung isang supplier ay SMC o Festo, no? Festo and SMC ang kadalasan. No, ayan, SMC reed switch, Festo, meron ding SIC, maraming mga sensor, Omega, SIC, no, SIC hydro-optic. Pero ito pinapakita yan na nandun siya sa body ng cylinder, sa katawan ng cylinder. Ayan, no. Ito. I think this one is a better representation because there's eto, no. So lagyan natin dito para naman medyo neat. Yan. So eto 'yon and eto. This one. We're just gonna have to copy, right? Hmm. Okay? Yan. So ang sinasabi ko para maintindihan so that you can so pwedeng eto, no. So we could use this as A0, no. Let me put another so that dalawa tayo, dalawa, no. So this one is A0 and then this is A1, no. So this is A1, right? A1, no. So pag sa reed switch nasa loob ng cylinder A0, A A1, right? So let me fully present this, right? So maliwanag ba? Is it clear? Ito is A0, this is A1. So ito rin 'yon. A0, etong buong to, A1, yung buo. So dalawa, 1, 2, 1, 2. When the cylinder forward here, so yung piston nakatapat right now here, no? So the piston is right here, no? It is detecting the because it's magnetic, no? So as of course bilog 'yan, no? Ayan ang piston, no? Piston 'yan, bilog. Nakatapat kayo niya, no? It's aligned here. So it's detecting the normally retracted position. But when it's going forward, no, it's going forward. Let me use another light. When it goes forward, when the cylinder goes forward like that, no. So the piston, which is from here, right? The piston here will move. So this is the piston plate. Okay. So this is the piston plate. This here, no, na may rod, it will come here. No, so magiging katapat na niya, makaka-align na niya ang A1. Yan, ito A1, no? So makakatapat niya yung A1 and this is magnetic. Okay? So yun ang nangyayari doon kaya pinakita kong mabuti yan, no? So this one, no? Pag nag-A plus, ano tamaan niya? A1, no? A1. Saan yung A1? Yung A1, where's that? A1 is this, right? So ito, A1. Pumunta na yung piston dito, tumapat, nag-align, no? So this reed switch is aligned in the piston and it's getting a signal. So what we're having here is this, right? There's a rod, no? Tinamaan to, it hit this roller, then the normally open, no, becomes closed now, no? So normally closed, no? Dati open eh. Naging closed, no? Normally closed now. Ayan. No, tatamaan 'yon, magpupunta yan sa baba. Yan. So, pinapakita ko lang yun sa actual para mas na-imagine kung ano nangyari. Now, so we're gonna continue this very fast, no? Kasi sequential lang naman. It's only sequential and everything is laid out, no? So, what we're gonna do is this, right? So, now it's A plus. A plus, tinamaan yung A1. No? Saan yung A1? Ayun, sa drawing natin, no? Sa sequence natin, A1. Tumama sa A1. Ito, A1. Sa drawing natin, saan yun? A1. Ito, yun. Diba? A0, A1. No? So yung switch dyan, no, tumama. Tinamaan tong A1. A1. Yeah? So pag tumama sa A1, yun ang susunod mo na ilalagay sa circuit. That's the next device that you're going to put in the circuit. No? So A1 to effect R2. No? So, asan yung R2? Wala pa tayong nakikitang R2, no? Tsaka yung sa B, no? Lalagyan natin yan. So, we will put latch here, R2, no? So, dito lalagyan natin ng R2, no? Because normally open will become closed and it will energize solenoid B. Solenoid B is responsible relay for that is R2 because when this is hit, no, it will become normally closed. It will energize R2. No, I'll just put like a energy raise there. Yeah, it will become a closed circuit, no? And then the line one will continue, line one here, yeah. So it will be energized, this closed, no, because of this. This coil will tend to close everything that is under its contact, no? Pag R2 lahat apektado. No? So it becomes closed, then the electricity will come here, it will go there in solenoid B, affecting B plus. Now that's the second, right? So this one, where's this? Yeah, A plus, B plus na tayo, no? So sa B plus, tinamaan niya yung ano, B1, no? B1. Paano nangyari 'yon? Yung B1, ito po 'yon, no? So yung B, 'di ba ito yung B, nag-B plus eh. Pag B plus niya, tinamaan tong sensor or electromagnetic switch which is B1. So yun ang isusunod, that's the next device that we are going to put in our diagram, no? Because this diagram has a story. It's not just a pictorial. Yeah? So ito ay B1, right? So para naman daw saan? Sa C+. So pag tinamaan na yung B1, magko-close to, so it can now deliver electricity here to energize R3. Pag na-energize yung R3, lahat ng R3, all the R3 will be affected. So we don't have yet R3 here. So we're gonna put R3 to affect solenoid C, no? Solenoid C kasi kanya-kanya nga yan, solenoid A, solenoid B, solenoid C, no? So ganyan. Ngayon, yung kuryente rito sa line 1, the current here, the power here will go through here and then this will become closed. Why? Because of this, no? Once the energy is given to R3 or relay coil, so because these circles are coil, meaning the winding, no? So there's a winding, that's why it's called coil. All the contacts will be affected, and this is R3. Before it's normally open, it becomes normally closed so that electricity can now pass through. And then this is in series, solenoid C is series, no? So it will energize solenoid C, no? That's why susunod natin. The next is solenoid C. Ayun, no? This is solenoid C. Now C, affected by R3. So solenoid C will touch C1. Paano nangyari yan? Because the solenoid will move forward, the solenoid will just move forward and then it will touch cylinder sensor C1. Huh? So this C cylinder will move and it will touch C1. So yun ang ilalagay natin. That's the next device that we are going to put in the ladder diagram or the electrical circuit. So C1, right? So that is connected to R4 in series, and then R4 contact is kind of arranged in parallel with this C, no, C1. So energizing R4. So what is also R4 responsible for? It is responsible for the two cylinders that are next in line, D plus and P plus, no? So yun ang mangyayari, no? R4. So wala pa naman tayong R4 dito, maglalagay tayo ng R4. R4. Dalawa yung pinapagana niya. Ano yun? Isang cylinder D. So solenoid D at nakaparallel tayo dyan. Ayan, oh. Solenoid E. So ito yung D, ito yung E. Kagagawa niya ng R4, no? Pag na-energize na tong R4, energize na parang E, R sun, it will close, no? Because any contact related to R4 will be affected. R4, this R4 and this R4 close, no? So ngayon, this time makakadaan na. The electricity can pass through R4 normally closed, and then it can energize on two ways. One is solenoid D and the other is solenoid E. So pupunta siya rito, energize yung solenoid D, and then dito pupunta siya para magkaroon ng E. So, ang effect niyan ay D plus tsaka E plus. No? So, basically, we're having this, right? Ayan, no? D plus tsaka E plus. Anong mga sensors naman ang tatamaan ng solenoid D tsaka E? Ng cylinder D tsaka E. Tingnan mo dito, ayan, no? Yung D, pag forward niya, tatamaan niya yung D1. Ito naman, E0, E1, no? Pag forward nito, tatamaan niya yung E1. So, D1 tsaka E1 ang dalawang electromechanical switch na tatamaan itong dalawang cylinders na to. So, it's gonna bump D1 and E1, no? Coding lang natin yan, D tsaka E, no? So, yun. So, dito, ang mangyari dyan, hanapin mo kung paano nangyari. Ano, di ba? R4, eto na yun, no? Solenoid D. Nung nag-forward na yung solenoid D, eto yun, no? Tinamaan niya yung D1 tsaka E1. Yun ang ilalagay mo dito, parallel, no? So, eto yung D1, eto ay E1, right? So, ilalagay mo sa R5, ilalatch mo kasi hindi pa naman siya huli. So, ngayon, pag tinamaan yan, dalawang sensor ang matatamaan niya, no? F sub 1 tsaka G sub 1. Saan yun? Dito. F1 tsaka D1. Saan ba yung F natin? Ay, D ba tsaka E? D tsaka E, sorry. No? So, D tsaka E. Saan ba yun? Ayun. Di ba yung D? Let me put another color so that it will be done. So, yung D natin, the cylinder rod of the cylinder D will go and then it will bump this. It will hit, no? Then this one is energized. No, this solenoid. This one is energized. The cylinder port here, right? And then there's air, and then there is this movement, no? Tatamaan niya yung E1. So E1 tsaka D1. So balik tayo. We're gonna go back here sa diagram. No? So D1, ayun yung D1 and E1. Of course, ginawa lang natin ng R5 para may latch dito. Okay? So moving on, yung D1, E1 will affect R5, no? Ito. No, so D1 and E1 will affect R5, responsible for, again, F tsaka G, no? So mangyari diyan, yung i-connect natin dito, no, nasa baba, ito yan. Nasa baba, ang pag-connect niyan ay tinamaan daw yung F tsaka G, no? So yung F, tatamaan yung F1, yung G is G1. So dito mo ilalagay yon sa susunod, no? So F1 and G1, no? Parallel, para naman bigyan ng signal yung R6. Para saan ba itong R6? Ang R6 naman ay responsable sa FG, no? Kasi ito R5 eh, no? R1, R2, R3, R4, R4, and then R5. Oh, R5 na pala. No, ito pala, R5, FG. So yung FG is R5, FG. Okay? So pag tinamaan yung FG, tatamaan niya yung F1 tsaka G1. Saan ba ito? So ito, tatamaan yung F1. Ito naman, tatamaan yung G1. No? Para magbigay ng signal doon sa ating R6 para pabalikin niya lahat, no? R6. R6 kasi ang magpapabalik, no? Relay responsible for the return of all the cylinders. Okay? So, yun ang gagawin natin at papakita natin dito. Madali lang yan kasi pare-pareho ng relay. Ang kulang na lang natin dito is yung R5 and R5 lang. No? So, yung R5 pala, dugturo lang natin dito. No? Maglalagay tayo normally open na R5, tapos dalawa na naman ang responsable niya. Ano yun? E, B, C, D, E, F, G. No? So, ito yung solenoid F. Ito ay solenoid G. Yan. Anong dalawang solenoid yon? Isa na nagpaandar, R5. Right? So, ito ay F plus tsaka G plus. No? So, F plus and G plus. Ayun po, F plus and G plus. Yan. No? So, yun ang magiging mangyayari dyan. Tapos yung F plus tsaka G plus, tatamaan yung F1 tsaka G1. No? So, eto, no? Hindi na magkasya. So, F1, tatamaan niya yung F1 tsaka G1 para tamaan niya dito, no? F1, G1 para tamaan niya yung R6, no? So, maglalagay ka dito ng F1, G1. Hindi tayo magkasya dito, no? So, dito, napalaki, no? So, F1, G1 ang lalagay natin dyan. No? Singit lang natin para, ano, para ma-visualize so that you can visualize what's happening. Kasi wala tayong mga actual device. No? So, F1, nalagay ko rito ay F1, no? Ito to. Meron ditong F1 tsaka G1. Ayan. F1 tsaka G1. F1 and G1. Nabasa doon yun. No? So, ang mangyayari dyan, yung F1 tsaka G1, no, we are nearing the close of this lecture. So, yung F1, G1, yun ang magpaparesponsable sa reset. Yan, sa reset. Ito. Okay. So, lalagay natin dito ay F1, G1, no, ang nagpangyari sa reset. Pero hindi mo nalalagay rito yung reset. Dito mo siya ilalagay, no? Dito sa pinakahuling yung contact ng huling relay mo, ilalagay mo sa una in series before the first relay coil. So, R7. Okay? So, dito naman, ang mangyari dyan is yung R6. No? So, yung R6, dalawa yung pinapagana. Ano yung pinapagana niya? Yung R6, punta ka dito sa R6 dito. R5. R5 pala ito. Yung R6. Ito pala, lahat papaganahin niya. No? R5. Ito na, FG na to, no? FG yung R6, pampatay yon, no? Sorry, hindi pala dito. Dito na lang, no? So, R6, normally close. R6, normally close. R6, normally close. At R6, normally close. So, dalawa rito, tsaka dalawa dito, 4, 5, 6, 7. Yan, no? So, yan na yung, ano, yung ating sequence, no? Tapos, pag tinamaan na yon, yung R7 naman dito, no, ay gagana because of the sensors na marami, no? So mula A0 hanggang hanggang G1, no? So yun ang gagana ng sensor. No? So yun ang ating circuit. No? So para mabilis lang i-recap ko na lang, no? Para mabilis. So ganito. Ito yung line 1, ito yung final answer. Line 1, line 2. Ito naman yung power circuit, no? Power circuit, no? So ito ang tinatawag na control circuit. Ito naman ay power, no? So lagyan natin inclined, medyo inclined natin, yan. Power circuit. Okay? So ngayon, ilang cylinder ba ang nakuha natin? How many cylinders did we use? So we were able to use 7, right? Because A plus, B plus, C plus, D and E minus, F and A, B, C, D, E, F, G minus, no? And then here is A minus, B minus, C minus, D minus, E minus, F minus, G minus. Yan. So yung sequence natin. So all we have to do is to put this line 1, line 2, and this just the continuation because we don't have space for continuous vertical manipulation. So we just put on the right portion. So what we're gonna do is to put all the relays concerned. How many relays do we have? R1, R2, R3, then R4, R5, and R6, R7 for the reset. No? So we're gonna lay out 7 here. No? So look at this. 1, 2, 3, 4, 5, 6, 7. So we're gonna name each relay with their corresponding address. R1, R2, R3, R4, R5, R6, R7, right? And then the responsibility for each relay. So this one is responsible for A plus, R2 is responsible for B plus, R3 is for C plus, R4 I think has two responsibilities, D and E minus. What about R5? Same, F minus and G minus. What about R6? It's responsible for, are we correct? A, B, C, D, E, F, G, right? A, B, C, D, E, F, G. So ilan ba talaga to? A, B, C, then D, E, F, G. Okay. 1, 2, 3. Tapos 4. This is R4, R5, then R6, return, R7 for reset. Okay, so A plus, B plus, C plus, D, E, F, G. This is the return, right? So plus, 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 plus. This is the minus. A minus, B minus, C minus, D minus, F minus, and G. 1, 2, 3, 4, D, E. F minus Q minus. So return. All the return will be the responsibility of R6. And it's gonna be the reset. Okay, how many power devices do we need to control? So of course we have how many? Six. Yeah. So we're gonna put here, right? So solenoid A, solenoid B, solenoid C, solenoid D. I think seven, right? One, two, three, four, five, six. So one, two, three, four, five, six, seven. Right? So we could put a name, right? So solenoid A, solenoid B, solenoid C, solenoid D, solenoid C, solenoid A, B, C, D, E, F, solenoid F, solenoid G. Right. Okay. So what we're gonna do? Kompleto na. So it's a start, normally open. This one is normally close, stop. Then the last coil for contact for the last coil. Ang last coil natin, our last coil is R7. So we will put a normally closed contact just before the first relay coil. So this is gonna be R7. This is gonna be stop, push button. This is gonna be start, push button, right? So this one, this one, this one, this one, this one, this one, and this one. So right now, I'm gonna just make an outline, like a hairline here. So that's it's just a guide. So everything is just we have to latch, no? So we have to latch or parallel line with the with the sensor or with the electromechanical switch, right? So here we have to do some pre-setting. No, so before R1, no, R1 should be the one. No, before R2, R1, it will pass R1. So R2 will not be energized if it's not coming first, no, via R1, and R3 will not be energized if it were not for R2. R4 will not be energized if R3 will not energize first. So these things should happen first. Now, in a sequence, these things above should happen first. So before you can go to the next. No? So R4, R3, R5, R4, R6, before it's going to happen, it can come through R5, and R7 is R6. Okay. Now this is the reset. No? So R1, R2, no, whatever appears here, it will go there. Whatever appears here, going there. So this is R3 coming from this, right? So this is R4 coming from this, no? R5 because of this, no? It should be the latch. Then this one is R6, yeah. Reset. No, we don't have we don't it's not allowed actually to have reset in the last the there should be no reset latch, no, in the reset coil. So this is the coil, no, nothing here, right? Only here you put the before the first coil, right? So now we're kind of complete. Now A plus, now when this happened, it will touch A1. So you put A1 here, no? So that's the sensor that you are going to put here before the preset. So A1. This one will touch B1. So you're gonna put here B's of 1, no? That's the sensor in charge. Now here's C plus or C1. That is what you're going to put here as your triggering sensor. This we have two, D and E. So that's gonna be D1 and E1. So where do you put that here, no? So parallel D1 and E1, right? So E1. Okay? It will touch two more, FG. When the cylinder is F forward and cylinder G forward, it's gonna touch to extremely forward position sensor. So that's gonna be F1 or normally open. I could call this F1, and that is G1, right? G1. Yeah. Now F1 and G1. So you're gonna put it here, and then still latch because of R6. Then when R6 is coming, so it will touch what? Oh, so many. So A, B, C, D. Now you can just have one or two here. No? So A0, B0, or C0 in parallel. No? In parallel, right? So you're gonna put that. What? So now that's the pretty much the control circuit. No? So this one A0, B0, or C0, then it's parallel, right? And then these are seven. You put the contact of this last coil to the first, now in series with the first coil. Now what about here? All the normally open contact will be the forward. So one, two, three, four, five, 6, 7. So for A plus, no, ano yun? The relay responsible is R1. So you're gonna put R1 here, right? For solenoid B, no, A plus. What about B plus? Who is affecting B plus? So R2. So you put R2 here. What about C plus? C plus is the responsible is R3. So you put R3 here, right? So basically you already have the forward position. But what about the cylinder D and E, R4. So you put R4, right? So R4 ang responsable sa D at R4 din ang responsable sa E, no? Same sila, same. Okay? Then what about F and G? So same din. Now F and G, so F and G, the responsible is R5. Now, so R5, you put R5 here. R5, R5, no? Or you could put a line here, same, no? But you can have also an individual like that, no? So what about the retract? The retract is very easy. It's just one relay, no? R6. No, to effect all these retractions from each cylinder, you just put R6, and for retract, we're gonna put the normally closed relay contact. So what is that normally closed relay contact? To effect the retract of all the cylinders, R6 from R5, R6, right? So put R6 to all these lines. So R6, retract A, R6, retract B, R6, retract C, then R6 to retract D and E, right? And then F and G is R6, right? Then when that happens, the cell they will all go back or come back, and then they will touch all the retracting position sensor, no? Ano yun? Yung A0. This is for A0, B0, C0, D0, E0, F, small f0, and G0. Yun yun. No, ito yun, no? So, tinan mo. A0, B0, C0, B0, and so on and so forth para makapunta siya sa reset. Kasi ito preset na. Reset is R7 o maalis to, R7, mag-open, patay lahat yan. No? Kasi na-open yung R7 eh. Kaya ito, R7 ang nag-reset pero galing yan actually sa R6, no? Ang huling pang reset is R7, but the R6 eto, ang R6 pa lang na to ay papatay na or magpapabalik na sa lahat ng cylinder rod. Balik kayo kasi R6, no? Paano nangyari yan? Pag na-open to, normally closed yan eh. Right now, this normally closed. When this is energized, when the coil of R6 is energized, the status will gonna change. It's going to change. So R normally closed will become normally open and giving no signal to solenoid A. Ganun din, no? R6 giving no signal to solenoid B, C, D, E, F, G. Hanggang FG, R6 lang naman, ika-cut. The R6 contact, normally closed, will be open, so it's gonna cut all the electricity or the current flowing in that path. No? So balik lahat, it will go back. No? And then the R7, when energized, it will energize R7 here, the normally contact, and then it will become open and all will be cascading. So this is the answer for that number 3 problem in the uh, final exam. No? So as what we have here. You know? So A plus B plus C plus forward, DE forward, FG forward, and the other thing is all the forwarded cylinders will now retract. Ito, no? So this here will happen because of R6. No? So this, no? So this here, is responsibility of R6 will just retract all the cylinders. Okay? So that's the answer for this number 3 problem in our exam. And I hope you were able to grasp the solution and somehow it enlightened you. So that's all for this. No, sorry for a bit extension of the class. No, so anyway, I'll check. I already checked your paper, and this evening I will post your final grades. No, because it's needed. The deadline for the posting of grade for the graduating students is today. That's why I just took the liberty for explaining the solution so that that will be clear to your mind. No? So thank you very much and have a good afternoon.